The Windows API, informally WinAPI, is Microsoft's core set of application programming interfaces available in the Microsoft Windows operating systems. The name Windows API collectively refers to a number of different platform implementations that are often referred to by their own names. See the Versions section. Almost all Windows programs interact with the Windows API. On the Windows NT line of operating systems, a small number use the native API. Developer support is available in the form of the Windows Software Development Kit, providing documentation and tools necessary to build software based upon the Windows API and associated Windows interfaces. The Windows API is primarily focused on the C programming language in that its exposed functions and data structures are described in that language. In recent versions of its documentation, however, the API may be used by any programming language compiler or assembler capable of handling the low-level data structures along with the prescribed calling conventions for calls and callbacks. Similarly, the internal implementation of the API's functionality has been developed in several languages. Historically, despite the fact that C lacks any notion of object-oriented programming, the Windows API as well as Windows itself has sometimes been described as object-oriented. There have also been many wrapper classes and extensions for object-oriented languages that makes this object-oriented structure more explicit. For instance, Windows 8, while still providing the Windows API, also provides the WINRT API, which is implemented in C++ and is object-oriented by its design. Overview. The functionality provided by the Windows API can be grouped into 8 categories. Base services provide access to the fundamental resources available to a Windows system. Included are things like file systems, devices, processes, threads, and error handling. These functions reside in kernel.x, krnl286.x or krnl386.x files on 16-bit Windows, and kernel32.dll on 32-bit Windows. Advanced services provide access to functionality additional to the kernel. Included are things like the Windows registry, shutdown, restart the system, start, stop, create a Windows service, manage user accounts. These functions reside in advp32.dll on 32-bit Windows. Graphics device interface provides functionality for outputting graphical content to monitors, printers and other output devices. It resides in gdi.x on 16-bit Windows, and gdi32.dll on 32-bit Windows in user mode. Kernel mode GDI support is provided by Win32k.sys, which communicates directly with the graphics driver. User interface provides the functionality to create and manage screen windows and most basic controls, such as buttons and scroll bars, receive mouse and keyboard input, and other functionality associated with the GUI part of Windows. This functional unit resides in user.x on 16-bit Windows, and user32.dll on 32-bit Windows. Since Windows XP versions, the basic controls reside in comctl32.dll, together with the common controls. Common Dialog Box Library provides applications the standard dialog boxes for opening and saving files, choosing color and font, etc. The library resides in a file called commdlg.dll on 16-bit Windows, and comdlg32.dll on 32-bit Windows. It is grouped under the user interface category of the API. Common Control Library gives applications access to some advanced controls provided by the operating system. These include things like status bars, progress bars, toolbars and tabs. The library resides in a DLL file called comcontrol.dll on 16-bit Windows, and comctl32.dll on 32-bit Windows. It is grouped under the User Interface category of the API. Windows Shell component of the Windows API allows applications to access the functionality provided by the operating system shell, as well as change and enhance it. The component resides in shell.dll on 16-bit Windows, and shell32.dll on 32-bit Windows. The shell lightweight utility functions are in schwapi.dll. It is grouped under the User Interface category of the API. Network services give access to the various networking capabilities of the operating system. Its subcomponents include NetBIOS, WinSock, NetDir, RPC, and many others. This component resides in netip32.dll on 32-bit Windows. The Internet Explorer web browser also exposes many APIs that are often used by applications, and as such could be considered a part of the Windows API. Internet Explorer has been included with the operating system since Windows 95 OSR2, and has provided web-related services to applications since Windows 98. Specifically, it is used to provide an embeddable web browser control, contained in shdocvw.dll and mshtml.dll. The URL moniker service, held in elman.dll, which provides COM objects to applications for resolving URLs. Applications can also provide their own URL handlers for others to use. An HTTP client library which also takes into account system-wide proxy settings. However, Microsoft has added another HTTP client library called WinTTP.dll, which is more lightweight and more suitable for some applications. A library for assisting with multi-language and international text support. Direct text transforms, a set of image filter components. XML support. Access to the Windows address books. Multimedia. The classic Windows Multimedia API is placed in winmm.dll and contains functions to play sound files, send and receive MIDI messages, access joysticks and other features of the so-called MCI subsystem of Windows. Apart from that, Microsoft has provided the DirectX set of APIs as part of every Windows installation since Windows 95 OSR2. DirectX provides a loosely related set of graphics and gaming services, including Direct3D for hardware-accelerated 3D graphics, Direct2D for hardware-accelerated 2D vector graphics, Direct Sound for low-level hardware-accelerated sound card access, Direct Input for communication with input devices such as joysticks and gamepads, Direct Play as a multiplayer gaming infrastructure. This component has been deprecated as of DirectX 9 and Microsoft no longer recommends its use for game development. Microsoft also provides several APIs for media encoding and playback. Directshow, which builds and runs generic multimedia pipelines. It is comparable to the GStreamer framework and is often used to render in-game videos and build media players. Directshow is no longer recommended for game development. Media Foundation, a newer digital media API that is intended to replace Directshow. Program interaction. The Windows API mostly concerns itself with the interaction between the operating system and an application. For communication between the different Windows applications among themselves, Microsoft has developed a series of technologies alongside the main Windows API. This started out with dynamic data exchange, which was superseded by object linking and embedding and later by the component object model, automation objects, ActiveX controls, and the .NET framework. There is not always a clear distinction between these technologies, and there is quite a lot of overlap. The variety of terms is basically the result of grouping software mechanisms that relate to a particular aspect of software development. Automation specifically relates to exporting the functionality of an application or component so that it can be controlled by another application, instead of just by a human user. .NET is a self-contained general methodology and technology for developing desktop and web applications written in a variety of just-in-time, compiled languages. Windows.par is a Pascal Delphi unit which contains the Windows-specific API declarations. It is the Pascal equivalent to Windows H, used in C. Wrapper libraries. Various wrappers were developed by Microsoft that took over some of the more low-level functions of the Windows API, and allowed applications to interact with the API in a more abstract manner. Microsoft Foundation class library wrapped Windows API functionality in C++ classes, and thus allows a more object-oriented way of interacting with the API. The Active Template Library is a template-oriented wrapper for COM. The Windows Template Library was developed as an extension to ATL, and intended as a lightweight alternative to MFC. Also notable are some of Boland's offerings. Object Windows Library was released to compete with MFC, and offered a similar object-oriented wrapper. Borland later deprecated it in favor of the Visual Component Library, which is written in Object Pascal and available in both Delphi and C++ Builder. Most application frameworks for Windows wrap the Windows API. Thus, the .NET framework and Java, likewise any other programming languages under Windows, are wrapper libraries. Windows API Code Pack for Microsoft .NET Framework is a .NET wrapper library for Windows API. History. The Windows API has always exposed a large part of the underlying structure of the Windows systems to the programmer. This has had the advantage of giving Windows programmers a great deal of flexibility and power over their applications. However, it also has given Windows applications a great deal of responsibility in handling various low-level, sometimes tedious, operations that are associated with a graphical user interface. Charles Petzold, writer of several books about programming against the Windows API, has said, "The original Hello World program in the Windows 1.0 SDK was a bit of a scandal. Hello C was about 150 lines long, and the Hello RC resource script had another 20 or so more lines." Veteran programmers often curled up in horror or laughter when encountering the Windows Hello World program. Over the years, various changes and additions were made to the Windows operating system, and the Windows API changed and grew to reflect this. The Windows API for Windows 1.0 supported fewer than 450 function calls, where in modern versions of the Windows API there are thousands. However, in general, the interface remained fairly consistent, and an old Windows 1.0 application will still look familiar to a programmer who is used to the modern Windows API. An emphasis has been made by Microsoft on maintaining software backwards compatibility. To achieve this, when developing a new version of Windows, Microsoft sometimes had to implement workarounds to allow compatibility with third-party software that used the previous version's API in an undocumented or even illegal way. Raymond Chen, a Microsoft developer who works on the Windows API, has said, "I could probably write for months solely about bad things apps do and what we had to do to get them to work again. Which is why I get particularly furious when people accuse Microsoft of maliciously breaking applications during OS upgrades. If any application failed to run on Windows 95, I took it as a personal failure." One of the largest changes the Windows API underwent was the transition from Win16 to Win32. While Win32 was originally introduced with Windows NT 3.1 and Win32's allowed usage of a Win32 subset before Windows 95, it was not until Windows 95 that widespread porting of applications to Win32 began. to ease the transition in Windows 95, both for external developers and for Microsoft itself. A complex scheme of API thunks was used that could allow 32-bit code to call into 16-bit code and vice versa. Flat thunks allowed 32-bit code to call into 16-bit libraries, and the scheme was used extensively inside Windows 95's libraries to avoid porting the whole OS to Win32 itself in one chunk. In Windows NT, the OS was pure 32-bit, and only generic thunks were available to thunk from Win16 to Win32. As for Windows 95, the platform SDK shipped with a compiler that could produce the code necessary for these thunks. The 64-bit version of Windows also capable of running 32-bit application. The syswow64 folder located in the Windows folder on the OS drive contains several applications to support 32-bit applications versions. Almost every new version of Microsoft Windows has introduced its own additions and changes to the Windows API. The name of the API, however, remained consistent between different Windows versions, and name changes were kept limited to major architectural and platform changes for Windows. Microsoft eventually changed the name of the then-current Win32 API family into Windows API, and made it into a catch-all term for both past and future versions of the API. Win16 is the API for the first 16-bit versions of Microsoft Windows. These were initially referred to as simply the Windows API, but were later renamed to Win16 in an effort to distinguish them from the newer 32-bit version of the Windows API. The functions of Win16 API mainly reside in the core files of the OS, kernel.x, usev.x and gdi.x. Despite the file extension of X, these actually are dynamically linked libraries. Win32 is the 32-bit API for modern versions of Windows. The API consists of functions implemented, as with Win16, in system DLLs. The core DLLs of Win32 are kernel32.dll, user32.dll, and gdi32.dll. Win32 was introduced with Windows NT. The version of Win32 shipped with Windows 95 was initially referred to as Win32C, with the C standing for compatibility, but this term was later abandoned by Microsoft in favor of Win32. Win32s is an extension for the Windows 3.1x family of Microsoft Windows that implemented a subset of the Win32 API for these systems. The S stands for subset. Win64 is the variant of the API implemented on 64-bit platforms of the Windows architecture. Both 32-bit and 64-bit versions of an application can be still compiled from a single codebase, although some older APIs have been deprecated, and some of the APIs that were already deprecated in Win32 were entirely removed. All memory pointers are 64-bit by default, so the source code has to be checked for compatibility with 64-bit pointer arithmetic and rewritten as necessary. Wince is the implementation of the Windows API for the Windows CE operating system. Other implementations. The Wine project provides a Win32 API compatibility layer for Unix-like platforms, and is a compatibility layer between Linux kernel API and programs written for the Windows API. ReactOS goes a step further and aims to provide an implementation of the entire Windows operating system, working closely with the Wine project to promote code reuse and compatibility. DOS Win32 and HXDOS Extender are other projects which emulate the Windows API, allowing the execution of simple Windows programs from a DOS command line. Odin is a project to emulate Win32 on top of OS/2, superseding the original WinOS/2 emulation, which was based on Microsoft code. Other minor implementations include the MEWEL and Zinc libraries, which were intended to implement a subset of the Win16 API on top of DOS. Windows Interface Source Environment was a licensing program from Microsoft which allowed developers to recompile and run Windows-based applications on Unix and Macintosh platforms. Wise SDKs were based on an emulation of the Windows API that could run on Unix and Macintosh platforms. Efforts towards standardization included Sun's public Windows interface for Win16, Willows Software's application programming interface for Windows for Win16 and Win32, and ECMA 234, which attempted to subject the Windows API to binding standardization. Compiler support. To develop software that utilizes the Windows API, a compiler must be able to use the Microsoft-specific DLLs listed above. The compiler must either handle the header files that expose the interior API function names, or supply such files by itself. For the C++ language, Zortek, Wacom, and Borland have all produced well-known commercial compilers that have been frequently used with both Win16, Win32s and Win32. Some of them supplied memory extenders, allowing Win32 programs to run on Win16 with Microsoft's redistributable Win32's DLL. The Zortek compiler was probably one of the first stable and usable C++ compilers for Windows programming, before Microsoft had a compiler for this language. For certain classes of applications, the compiler system should also be able to handle IDL files. Collectively, these prerequisites are known as the Microsoft Platform SDK. For a time, the Microsoft Visual Studio and Borland's Integrated Development System were the only IDEs that could provide this. Nowadays, the MingW and Cygwin projects also provide such an environment based on the GNU Compiler Collection, using a standalone header file collection to make linking against the Win32 specific DLLs simple. LCC Win32 is a C compiler maintained by Jacob Navia, free for non-commercial use. PelC is another freeware C compiler maintained by Pellerinius. Free Pascal is a free software object Pascal compiler capable of writing software based on the Windows API. The MASM32 package is a mature project providing support for the Windows API under Microsoft's macro assembler by using custom-made or converted headers and libraries from the Platform SDK. FASM allows to build Windows programs without the use of an external linker, even when running on Linux. Windows-specific compiler support is also required for the structured exception handling feature. This system serves a dual purpose. It provides a substrate upon which language-specific exception handling can be implemented, and it is how the kernel notifies applications of exceptional conditions such as dereferencing an invalid pointer or Stack Overflow. The Microsoft Borland C++ compilers had the ability to use this system as soon as it was introduced in Windows 95 and NT. However, the actual implementation was undocumented and had to be reverse-engineered for the Wine project and free compilers. C is based on pushing exception handler frames onto the stack, then adding them to a linked list stored in thread local storage. When an exception is thrown, the kernel and base libraries unwind the stack running handlers and filters as they are encountered. Eventually, every exception unhandled by the application itself will be dealt with by the default backstop handler, which pops up the Windows Common Crash dialog.